Hello guys, my name is Tanmay and my team members are Bindu and Shriya. Our project guide is P. Sailaja, Assistant Professor of IT Department. Our project name is Automatic Fish Feeder using IoT domain. Our abstract: an automatic fish feeder is a device that provides food for a fish at a predetermined time. It controls the fish feeding activities by combining mechanical and electrical systems. Fish overlooking has been seen to reduce the stress levels and boost our efficiency. It helps regulate our heart rate and blood pressure. Since everything nowadays uses smart technology, an automated fish feeder is a great device that we can implement to feed our fish with a click our button on our mobile phones. The IoT smart device uses wireless communication to release fish food in the tank when we command or schedule it to do so. Proposal: since everything nowadays is smart technology, this is a great device which we can implement. We use the Blink application, motor, driver, RTC, and the ESP32 as the main components of our fish feeders. The Blink application is used to customize our controls. It has a motor on and off button, and in addition it automatically sends out food every 1 hour. The focus of this project is its system design. In addition to the motor's on and off button, it displays the status of the Wi-Fi, the real-time clock, the motor, and even the status of the fish feeder, whether it is on or whether it is switched off. Existing systems. There are many different existing systems. There are traditional systems where you have to do everything manually without using any external devices. Then we have other systems which use devices such as Node MCUs that serves as a system's control modules, and Node MCUs also allow internet access for the system. Then we have other existing systems which checks the amount of food, the automatic feeding, the acidity level, and water replacement technology. This sometimes fails, which leads to algae outbreaks. So a solution for these existing systems is our proposed system. Now, activity diagram. So a user starts at the user interface and opens the Start app, which is the Blink application. If the data is connected, it goes to the next step. Otherwise, the data needs to be connected again. Next, in the scheduling step, the Blink application needs to be created a schedule. If the schedule is created, the fish will feed. Now, if the fish feed is not available, that means that the storage container needs to be refilled. Next, the Blink application will be able to control the fish feeding activities. So once the fish feeding is completed, you can say that the sequence is over. State chart diagram. So start with a mobile or unpowered data. Now we have to check if the connection is available. If it is not connected, we need to make the connection. Once the power is on, the mobile is now available for functioning. Now it uses the real-time database to read the real time. Once this step is completed, the data is sent into the Blink application and goes into the final state. Sequence diagram. First, we need to check the fish food quantity in the container manually. Next, we have to create a schedule from the user to the Blink application. And now the user has to press the Feed Now button in the Blink application. So once this is completed, the fish food will be fed. Once the feeding is completed, the Blink application will say that the feeding is over. Architecture diagram. If the ESP32 does not have a sufficient quantity, that means that the project will not get executed. So we need to make sure that the real-time data is being updated properly. So this can be shown in the mobile application. We can connect the ESP32 in our device using the hotspot in our mobile phones and connect it to our project. This is the circuit diagram. This is the execution.
This is the ESP32. It has a built-in Wi-Fi and Bluetooth. Coming to the Wi-Fi, we can connect to the internet directly via cloud, and then the Blink app can share the data. When the Wi-Fi is connected, ESP32 blinks, and we can also observe the same in the application. Next component we have is RTC. RTC stands for real-time clock. It will tell us what way the time is running. Based on the time we set, the motor will run. This is the power section, which supplies additional power to the driver. Next we have the L298 driver. This is used to make the motor run. We use the driver because the motor runs with 5 to 12 volts, but the controller only takes 3 volts. Since we can't give the power to the motor directly, we use this driver here. It takes the external power and adds it to make the motor run. Here we have the motor. This is the motor where the output for our project will be displayed. The power is supplied to our project via this entry point. Next, we have the blink application which we can use to control our project. We can see the real time and we can see the current date, and to see if the Wi-Fi is enabled, a blinking light indicates that it is enabled. Now we can click on the motor button to turn on our motor. Here the motor and the fish feeding status will be displayed on the blink application. Now after